Hello and welcome to D Creations Resources. We are looking at different concepts from mathematics, the subtopic linear algebra, and today's topic is solving a system of equations using row canonical form. If you recollect, in our previous episode we have seen in detail what row canonical form or row reduced form of a matrix is. We have seen what are its uses, and in fact solving linear systems of equations is one of the uses or applications which we are going to follow in this episode. And there are other applications as well. And there are unique properties. So when do you call a certain matrix to be in row canonical form or row reduced form? If it follows certain conditions. And what are those conditions? All the zero rows should be at the bottom of the matrix. The first non-zero entry in each row has to be to the right of the leading entry in the row above it. So for example, here you can see, or in the 1 in this third row is to the right of 1 in the second as well as first row. All the elements below and above the leading entry have to be 0, and the leading entry has to be equal to 1. So this is one of the simplest examples of a row canonical form of a matrix, a unit matrix. Coming back to our question, we have been given a system of equations. X minus 3y minus 2z is equal to 6, 2x minus 4y minus 3z is equal to 8, and minus 3x plus 6y plus 8z is equal to minus 5. Now what I would suggest is, instead of just watching this, please solve it simultaneously, so that then you will know where you are getting stuck or what is it that you don't know. That you will be able to understand if you are doing it simultaneously. Now, what is the first step? First step is rewriting this system in this format. What is this format? The first matrix is the matrix of coefficients. So 1 minus 3 minus 2, 2 minus 4 minus 3, minus 3, 6, 8. So you can see it same here. See, 1 minus 3 minus 2, it's the first row. 2 minus 4 minus 3 and minus 3, 6, 8. Then there is a matrix consisting of the variables. There are 3 variables here, x, y and z. So it's a column vector x, y, z. And lastly, it's a column vector again. And what are the entries? The entries are the numbers on the right hand side, the constants on the right hand side in the equation. So 6, 8 and minus 5. So this is how it is written. Now, for simplicity, we'll augment the matrix. That means we'll take this 6, 8, minus 5 inside because we want to perform the same operations. Now, if you recall, we had seen in the we had seen a while ago that this is for a 3 by 3 matrix, this is the row canonical form. So this is our destination. That means all the leading entries will have to be 1 and all other entries have to be 0. So that is what you want to do here. Can you just try it out on your own? You can just pause this video, try it out on your own, and if you are able to get it on your own, that will be the best thing. If you still have doubts, then you can watch this. Okay? Alright. So, the first column, you can see this is 1, 2, minus 3. And where do we want to go to? We want to go to 1, 0, 0. So what is the simplest operation that you would do? If you want to make this 2 as 0, you would have to subtract 2. And you can see that this element is 1. So if I multiply this element by 2, I would get that. So in simple terms, from row 2, subtract twice of row 1. See, R2, that is row 2, minus 2 into R1. R1 is row 1. Similarly, can you tell what should be the expression or the row operation that will be happening here? See, minus 3 you want it to become 0. That means you want 3 to be added. And when will you get 3? If you multiply this first row by 3. So, R3 plus 3R1. Can you see it here? Now, one thing that needs to be noted is these operations don't happen in isolation. They need to operate on each entry in the row. When you say R2 minus 2R1, just 2 is not going to go to 0. That is first thing. Minus 4 will also modify. And how will it modify? You have to add minus 2 into minus 3. Minus 2 into minus 3 is plus 6. So minus 4 plus 6 gives you 2. Similarly, see this entry. Minus 2 into minus 2, which is plus 4. So minus 3 plus 4 is 1. And the last entry, 6 into 2 is 12. So 8 minus 12 is minus 4. Similarly, even for row 3, you have to just add 3 into first row. So here minus 3 into 3 is minus 9. So if you add minus 9 to 6, it gives you minus 3. Similarly, minus 2 into 3 is minus 6. So 8 minus 6 gives you 2. And minus 5 into 3 is minus 15. No, sorry. You have to add 3 into row 1. So 6 into 3 is 18. And minus 5 plus 18 is 30. So you get this matrix. Of course, we are still far from where we want to go. Now, what is the next task at your hand? Look at second column. Now, this middle entry, instead of 2, you want to get 1. So, what is the simplest thing? Just divide it by 2. So, if you divide the entire row by 2, then you will get this as 1, you will get this as half, and you will get this as minus 2. Just recall that we had learnt about row operations. So you can add rows, you can multiply it by a constant, which is basically scaling of it, and then you can have a combination of that as well. Now look at the entry here. You want to make this minus 3 as 0. So what is the simplest thing you can do? You can subtract this minus 3 from it. So R1 minus R3. So this becomes 0. This was anyway 0. So no change here. And minus 2 also is going to become minus 4, because this is minus 2 into minus 2 minus 2. Okay, there is no cancellation here because the signs are opposite. So this is the expression. Now in the second column, what is left? This entry. We want to make this as 0. So how do you do it? Just multiply the second row by 3 and add. So when you do it, minus 3 plus 3, this will give you 0. Similarly here, when you add, you are going to get 7 by 2, and lastly you will get 7. Now in the third column, if you want to make this 1, simply you have to multiply it by its inverse. So 2 by 7 you need to multiply it with. And in the second case also, 7 multiplied by 2 by 7 gives you 2. So in fact, you can see here that one of the variables you already know. See, here you've got 1 and this was z. So you already now know that z is equal to 2. But we are not going to stop here. Usually when you do solve equations, we make a substitution there. We are doing a similar thing here, but in the matrices form. So what is the next step? You want to make both these entries as 0. And how will you do it? Well, to R2 you can add minus half of R3, and to R1 you can add plus half of R3. And when you do that, finally you would get 0, 0 as you wanted. This 0 is going to become 1 and minus 2 is going to become minus 3. Simple calculation. And now you can see that you have already reached the answer. See, this first 3 columns constitute now the coefficient matrix. So you can visualize the entire unit matrix here. The variable column remains intact. And lastly, 1, 3, minus 2. So it's as good as saying x is equal to this, y is equal to this, and z is equal to this. So x is 1, y is minus 3, z is 2. So this is a solution. X is equal to 1, y is equal to minus 3, z is equal to 2. So this is how row canonical form helps us in solving equations. And we are going to look at MCQ question also on this topic in the next episode. Thank you.